Hello, this is Algebra 2. We are in Chapter 6, Section 6. This is page 2 of the notes. We're given a couple examples on how to solve different types of equations. The first one is solving an equation with a rational exponent, and they're showing this to make sure you're good with rational exponents, not just the little radical signs, the square roots and cube roots. And that's good. I'm going to actually do this example twice, two slightly different ways. I want to really emphasize that combination between rational exponents and radicals. And then I also want to make sure that you see that you have options. So let's begin. The first step here is we need to take our original 3x plus 4 to the 2/3, and we know it's equal to 16. And you'd look at that and you'd say, okay, well that's nice, I suppose, but I don't like this to the 2/3 power business. And the way to fix that is to raise both sides to the 3/2 power. Of course, what you do on one side of an equation is necessary for the other. But the reason why you'd want to do that is because, remember, powers of powers, the exponents end up multiplying, and so that multiplies to 1. And so really on the left, as exciting as it looks right now, it's actually just plain 3x plus 4. And poof! Over on the right, you have 16 to the 3/2, and the book intends you to pause and rewrite this as 16 to the 1/2 to the 3rd, and then remember that 16 to the 1/2 really means square root of 16, and so that's really 4, so it's always like that to the 3rd, it's always like that to the 3rd, and so really it's 64. To be honest with you, you're probably realistically going to go ahead and use a calculator to simplify that out. So 3x plus 4 equals 64. Poof. Then you go ahead and subtract 4 from each side. So 3x equals 60. And then you're dividing each side by 3. I find it odd that the book decides to remind you how to do the Algebra 1 version. They take up a lot of time on the notes, a lot of space, reminding you how to subtract from each side and divide each side, which is, from my end, slightly frustrating because you're using precious space on something that's relatively easy compared to all the hard things that's new. Hey, whatever. Hey, look, it says the solution is 20. It also says check this in the original equation. That's wonderful. Go ahead and check it. Again, this might be the best time ever to use your calculator, to take 20, substitute it into the original equation, make sure you end up with 16. That's all well and good, but you know what? I'm going to do it again anyway. And I'm going to do it again because I want to show a different view on how it looks. So 3x plus 4 to the 2/3 equals 16. Now I want to make sure that we spend a moment and acknowledge that this is the same thing as saying 3x plus 4 cube rooted and then squared equals 16. And the reason why is because then we can go ahead and square root both sides, and you get plus or minus 4 out of the 16, and then cube root of 3x plus 4. And then you can cube both sides to get rid of the cube root, and you get 3x plus 4 equals 64, or 3x plus 4 equals negative 64. Now, there are two of them because of this plus minus business. If we just go look on the left first, it's the same as what you already saw. 3x equals 60, x equals 20. I'm going to underline that answer. I'm not going to box it yet. Over on the right, 3x equals negative 68. So x equals, was that negative 20 and, negative 20, negative 22, and 2/3. Okay, whatever. Then you can go ahead and substitute that in to both to both sides, and I think you'll end up that x equals 20 is the only one that works. So again, checking becomes more valuable. I understand that this version looks a little bit longer than the way it's written in the notes. If you prefer the way in the notes, that's fine. I wanted to expose you again to the fact that rational exponents, little fractions in your powers, mean radicals of different stripes. So, but let's move on to example 3, which is pretty lengthy here. We have x minus 2 equals square root x plus 10. So it says square each side. Well, I probably can just do that. Square root of x plus 10 squared is x plus 10. On the left, it's x minus 2 squared. Remember, the entire side of the equation has to be squared. You can't get away with just squaring each term. Because x minus 2 squared, remember that's x minus 2 times x minus 2. And if you FOIL that out, you get x squared minus 4x plus 4. On the right, you still have x plus 10. Okay? Moving it all over so it's equal to 0. It's a quadratic equation, which means you've got to have it equal to 0. All of our ways of solving quadratic equations only work when we can compare them with 0. So x squared minus 5x minus 6 equals 0. And then it's intended that you could factor this, which is just fine. If you were having some sort of brain fart, you could, of course, use the quadratic formula instead. Factoring this one is probably faster than the quadratic formula. X minus 6 times x plus 1. And so our two equations are x minus 6 equals 0 or x plus 1 equals 0. And so x equals 6 or x equals negative 1. Poof. Now we're like, yay, I'm done. I have two answers. Maybe. And the answer is actually probably not so much. So let's look at what's going on here. We think we have our answers of x equals 6, which I now need to write because of the way I changed my screen. X equals 6 or x equals negative 1. You already have that written on your paper. And then check. So we go ahead and we check, right? We put the 6 in first on the left. You're talking about 6 minus 2. There's that fun question mark on the equal sign thing that I talked about before. Is that really the same thing as the square root of 6 plus 10? And you look at that, you're like, okay, 6 minus 2 is 4. Square root of 6 plus 10 is 16. So we're talking about 4 and 4 is 4. The answer is yes. 4 is 4. Yay, happiness. So the go to the next line later. On the right, we're going to go ahead and check x equals negative 1. So we got negative 1 minus 2. Is that maybe equal to square root of negative 1 plus 10? So negative 1 minus 2 is negative 3. We got a square root of 9, and square root of 9 is 3. So is negative 3 3? And the answer is no. Sad face. Yeah, what can you do? So what's going on here is that sometimes these radical equations will give you answers that are not really answers. They're just poser answers. I don't know. They're pretending to be answers. And, you know, at the top of this it said extraneous solutions, which is a long, annoyingly voweled word. But it isn't that simple because you don't know ahead of time if the problem's going to have extraneous solutions. So the book makes it seem in these notes all nice and clear, like, oh, this one will work, and check it anyway. And you're like, why? It worked. And then, oh, this one may not work. Let's actually show checking. But you got to hold up. You actually have to check them all now. Anything with a radical in, you've got to check. So the only actual solution is, 6, there we go. And the apparent solution of negative 1 is extraneous. And that's a fun word meaning extra and erroneous and just bad in general. So 6 is the right answer. 6 is the answer of happiness. -1 is the answer of, like, I almost got there. I just, at the end, didn't check correctly. It's too bad. All right. Well, that's page 2. Thank you for watching.